Some of the most effective building techniques ever developed were banned. Not because they failed, because they worked too well. Your house will be demolished within a century. There is a farmhouse in Normandy built in the 1300s that is still being lived in today. 7 techniques separated them, and every single one was banned. No power tools, no cement mixers, no synthetic materials. And yet medieval builders constructed things still standing 800 years later, through wars, floods, fires, and 7 centuries of weather, while your render is already cracking. Modern buildings start failing within 30 years. Damp gets in. Foundations shift. Mold takes hold. Flat roofs fail. The average lifespan of a modern home in the developed world is 60 to 100 years, if it is maintained. The people who built Westminster Hall, the cathedrals of France, the castle walls of Germany, they built expecting those structures to outlast them by centuries. And they did. Every technique they used was designed to get stronger with time, not weaker. So when industrialization arrived and speed became more valuable than durability, those techniques were pushed out. Some were regulated away, some were simply abandoned. All of them were lost. This video reveals 7 of them. Like and subscribe, because what you are about to see has been buried for 200 years. Modern buildings use Portland cement mortar. It is rigid, fast-setting, and waterproof. It is also, over time, a death sentence for the walls around it. Portland cement is stronger than the stone or brick it holds together. When a wall moves, and all walls move, with temperature, with moisture, with settlement, the cement does not flex. It cracks. And once cement cracks, water gets in. And once water gets in, the wall begins to die. Medieval builders used lime mortar. Lime mortar is softer than the stone around it. When a wall moves, the lime absorbs the movement. It microcracks, and then it self-heals. The carbon dioxide in the air reacts with the calcium in the lime, recrystallizing the mortar over time. A crack that opens closes again. The wall keeps breathing. There are medieval walls where the original lime mortar has been doing this for 600 years, self-healing, every winter, every summer, every storm. Portland cement cannot do this. Once it cracks, the damage is permanent. Lime mortar was crowded out. Portland cement was faster to set, cheaper to produce, and required less skill to apply. Today, there are entire medieval buildings being damaged by restoration teams who fill joints with Portland cement, destroying the very walls they are trying to save. Walk past a medieval castle wall and you see 2 things: outer stone facing on one side, outer stone facing on the other. What you cannot see is what sits between them. Rubble, packed earth, broken stone, gravel, and lime, all compressed into a core that fills the space between the 2 outer faces. This sounds primitive. It is not. The rubble core does something a solid stone wall cannot. When a projectile hits it, a cannonball, a battering ram, the force of an earthquake, the energy disperses into the rubble. It does not shatter, it absorbs. In earthquake-prone regions of medieval Europe and the Middle East, rubble core walls were the standard. Builders had learned through generations of observation that a flexible wall survived what a rigid wall did not. Modern building codes do not permit unreinforced rubble core construction. The codes require engineered materials with measurable compressive strength. Rubble core walls cannot be tested in the laboratory the way concrete can. So, they were regulated out of existence. The irony, some of the most earthquake-resistant structures ever built used rubble core walls. And we banned them Because we could not measure them. Before plasterboard, before spray foam, before fiberglass bats, medieval builders insulated their walls with wattle and daub. The frame was wattle, thin branches woven like a basket between the timber uprights of a building. The filling was daub, a mix of clay, straw, animal dung, and sand, depending on what was locally available. Applied wet and allowed to cure, daub creates a dense, breathable wall panel that regulates moisture and temperature simultaneously. It absorbs heat during the day and releases it slowly at night. It allows moisture to pass through rather than trapping it behind it. It does not rot. And it can be repaired by anyone with access to clay and straw. There are wattle and daub panels in English timber frame buildings that have been in place since the 1400s. Modern building regulations require wall panels to meet fire resistance and structural standards. Wattle and daub fails these tests, not because it is dangerous, but because it cannot be standardized. Every batch of daub is slightly different. The industrial economy cannot work with different. So wattle and daub was replaced with plasterboard. A material that traps moisture needs replacing every time it gets wet and lasts decades, not centuries. In parts of medieval Norway, Sweden, and Scotland, builders laid compacted sheep's wool beneath the foundations of timber buildings on wet ground. Sheep's wool does not rot in wet conditions the way most organic materials do. The lanolin in the wool, the natural wax that waterproofs a fleece, continues to repel moisture long after shearing. Compacted wool also distributes weight evenly across soft ground, acting as a flexible cushion between the building and unstable earth below. Some of these wool-founded buildings stood for centuries on ground that would have swallowed a modern concrete slab. Modern foundations require concrete, steel, and compacted hardcore. Sheep's wool is not on the approved list. The knowledge that it worked faded as concrete poured by machines replaced material laid by hand. Medieval builders hardened earthen floors using ox blood. Fresh ox blood, worked into the surface of a compacted earth floor and allowed to cure, polymerizes as it dries. The proteins bind the soil particles together, creating a surface that is hard, dust-free, and resistant to water penetration. The same technique was used in lime renders. A small quantity of blood added to the mix increases workability and final hardness. Roman builders used it. Medieval builders refined it. It was still in use in rural Europe into the 19th century. It was replaced not because it stopped working, but because industrial concrete made earthen floors obsolete. The skill disappeared with the craftsmen who knew it. Modern, sustainable construction has rediscovered this technique. Zero carbon footprint, zero synthetic chemistry, and a 1,000-year track record. Medieval builders in hot climates built without air conditioning, not because they did not care about heat, but because they designed buildings to move air without mechanical assistance. Thick stone walls absorbed heat during the day and released it slowly at night. Internal courtyards created chimney effects. Hot air rising drew cooler air in from lower openings. Towers caught prevailing winds and channeled them through the building. Window openings were sized not for the view, but for the airflow. In the Islamic world, wind catchers, towers designed to capture and direct air down into buildings, kept interiors comfortable in climates regularly exceeding 40 degrees Celsius. No electricity, no refrigerant, no compressor. Modern buildings are sealed boxes dependent on mechanical ventilation. When the power goes out, they become uninhabitable within hours. The medieval building breathed on its own. Passive design was not banned. It was abandoned. Faster to build a sealed box and bolt an air conditioning unit to the wall than to think carefully about orientation, mass, and airflow. The skill of designing for climate became rare. Then it became almost extinct. In Japan and in parts of medieval Europe, timber frame construction developed a property that modern engineers spent decades trying to replicate in steel and concrete. Flexibility. A timber frame building, with its mortise and tenon joints, its wooden peg connections, its ability to rack under lateral load, does not resist an earthquake. It rides it. The frame flexes, the joints move, the building deforms slightly and then returns. The energy passes through it rather than shattering it. The 1995 Kobe earthquake destroyed modern concrete buildings across the city. Traditional timber frame buildings in the same area survived with minor damage. Engineers studied them for years afterwards. The knowledge that timber frame could outperform reinforced concrete in seismic events was not new. Medieval builders had been constructing this way for centuries. It had simply been dismissed when concrete and steel became the default. The craft knowledge of how to cut, fit, and peg a timber frame to perform this way takes generations to develop. We have been rebuilding it from almost nothing. Every one of these techniques was replaced during the same period, the Industrial Revolution of the 18th and 19th centuries. Not because they stopped working. They were still working perfectly in the buildings that used them. Not because something better came along. In most cases, what replaced them was inferior in durability, in sustainability, and in long-term performance. They were replaced because they were slow, because they required skill, because they could not be standardized, packaged, and sold at scale. An economy that needs to build fast and sell more cannot afford craftsmen who take years to learn their trade. It cannot afford materials that cure slowly or walls that need to breathe. It needs product, repeatable, shippable, replaceable product. So the knowledge was allowed to die. The craftsmen retired without apprentices. The techniques became curiosities studied by historians rather than skills practiced by builders. And now, we live in buildings designed to last one mortgage cycle. We spend billions every year repairing structures that should not need repairing. We heat and cool sealed boxes that medieval builders would have found absurd. We pour concrete that cracks and fails while 800-year-old lime mortar is still quietly self-healing in the walls around us. The farmhouse in Normandy is still standing. Your house has a demolition date already built into its foundations. We had the knowledge. We chose profit over permanence. And every year, somewhere, another medieval building teaches us what we should never have forgotten. If this changed how you see the walls around you, hit like and subscribe to Unsealed History. We are just getting started.